morning to one and all. Myself Pawan Kumar, Assistant Professor from Vignan Institute of Technology and Science. Now I want to discuss about root locus and construction rules of root locus. Root locus root means the roots of the characteristic equation, and locus means path. Here root locus means the locus of the path of poles by varying the value of k from 0 to infinity, that is called root locus. Coming to the root locus rules, the first rule is symmetrical. Root locus is symmetrical about real axis. If you take any transfer function, all roots are symmetrical about real axis, and maybe root lies on imaginary axis. So root locus is symmetrical about real axis, that is the rule 1. Coming to the rule number 2, the number of root locus branches. The number of root locus branches or number of loci. Now number of root locus completely depends on poles and zeros. Now let us assume that p is the number of poles and z is the number of zeros. If p greater than z, the number of root locus branches equal to p. If p less than z, the number of root locus branches is equal to z. Now coming to the rule number 3, number of real axis root locus branches. Here some rules are there. First we have to locate the poles and zeros on pole 0 plot. Poles are represented by cross mark and zeros are represented by 0. Now here always the root locus path is start from pole and with 0 by varying the value from k 0 to infinity. Suppose we are assuming this diagram. Here p plus z means poles and zeros odd, then only root locus branches exist, otherwise root locus branches does not exist. If we take some particular point p, from that point right side p plus z, poles and zeros count should be odd, then only root locus exist, otherwise root locus does not exist. Suppose we are assuming some transfer function g of s into h of s is k into s square plus 2s plus 2 by s square into s plus 2 into s plus 4 into s plus 6. Now this is the pole 0 plot of root locus. Coming to here at -1, I am assuming one point here -1, the right side two poles are there, means poles and zeros count here even, so there is no root locus. Coming to here -2.5 or 3, the poles and zeros count is odd, so root locus branches exist. Suppose here -5 we are taking, at -5 the number of poles and zeros count is even, so root locus branches does not exist. Coming to the rule number 4, angle of asymptote. It is the root locus branch which are approach to infinity. It is the root locus branch which are approach to infinity. The number of asymptotes is, or angle of asymptote is 2q plus 1 into 180 degrees by p minus z. Here q is 0, 1 and so on, p minus z minus 1. P is the number of poles and z is the number of zeros. This is the angle of asymptote. Coming to the rule number 5, centroid. Centroid is the intersection point of angle of asymptotes. Suppose you take a centroid, sum of real parts of poles are minus sum of real parts of 0 by p minus z, where p is the number of poles and z is the number of zeros. This is the centroid. Here centroid may or may not be lies on root locus. Suppose we take for example a transfer function k by s into s square plus 2s plus 2. First we have to find angle of asymptotes. For this angle of asymptote we have to substitute the formula 2q plus 1 into 180 degrees by p minus z plus or minus, okay, 2q plus 180 p minus z. Here zeros are 0, zeros are the numerator, make it denominator equal to 0, that is 0. Now poles is nothing but roots of the denominator, zeros are the roots of the numerator. Here zeros are there is no zeros, and poles are 3, order of the denominator is 3, so poles is 3, p minus z minus 1 equal to 2. Now coming to the centroid. Centroid is the intersection of angle of asymptotes. Here sigma are real parts of poles minus 0. Here zeros are not there. Here how many poles? Only 3 poles. 0, another one is minus 1 plus j, minus 1 minus j. Here we have to take real parts only. 0 minus 1 by 3. That is the centroid. Next rule is breakpoint. Breakpoint, the point at which two or more poles meet or directly locate at any location is called breakpoint. The point at which two or more poles meet or directly located, breakpoint. Breakpoints are two types. First one is breakaway point or break in point. Breakaway. First I want to discuss about breakaway point. The point at which breakaway point. The point at which the root locus branches leave the real axis is called breakaway point. The points at which the root locus branches leave the real axis. The point at which root locus branches enter the real axis is called break-in point. Here the angle at which these breakaway point is by plus or minus 180 by r. R means number of poles are 0. Suppose two poles are adjacently placed. If root locus is exist, then breakaway point is leaves by an angle of plus or minus 180 by r. R means 2 here. 180 by r. Breakaway point is exist when two poles are adjacently placed. When two zeros are adjacently placed, then the point is called break-in point. Suppose instead of poles we have to take zeros. The root locus branch enter into the zeros. That is called as break-in point. The point at which two poles meet the real axis is called break-in point. The point at which two poles leave the root locus branch is called break-in point. Now we have to the procedure to find out the breakpoints. First we have to form the characteristic equation. We have g of s into h of s, or gh is the open loop transfer function. First we have to find out the characteristic equation, then separate the constant k equal to f of s. Now we have to differentiate with respect to s, because dk by ds equal to 0. Differentiation of constant equal to 0. Then if k, then we got 2 or 3 values. Suppose based on the equation we are getting some points by solving dk by ds equal to 0. Now if k is positive, it is a valid breakpoint. If k is negative, it is an invalid breakpoint. Depending upon the k value, we are telling the breakpoint is exist or not. Suppose we are assuming some transfer function, open loop transfer function, k by s into s plus 2 into s plus 4. Now we have to form the characteristic equation. The characteristic equation is 1 plus g of s into h of s. This is the final characteristic equation. First we have to take this equation, k equal to minus s cube plus minus 6 square s6s square plus 8s. This is our k value. Now we have to make the differentiation equal to 0. By solving this equation we are getting two variables, s equal to minus 0.8 minus 3.2 values we got. Now substitute these two values in our original k equation. Now if k is positive, here if you substituting s equal to minus point in k, it is positive, then it is a valid breakpoint. In the same manner we are substituting s equal to minus 3.15. We got k is negative, so it is invalid breakpoint. Coming to the next rule, that is intersection with imaginary axis. You have to find the intersection point with imaginary equation. For find the procedure to finding intersection point on imaginary axis, first one is form a characteristic equation. Now g of s into h of s is the open loop transfer function. Now we have to find the characteristic equation by using Routh or wedge test. Routh tabular form, we can calculate the marginal value of k. So now form a auxiliary equation. Find the intersection point. Depending upon k value, we are telling valid intersection point or invalid intersection point. If k marginal value is positive, then only it is valid, otherwise it is invalid breakpoint. Next one, we have to suppose, for example, I am taking one transfer function. G of s into h of s. G of s into h of s equal to k by s into s plus 2 into s plus 4. First we have to form the characteristic equation. 1 plus g of s into h of s equal to 0. Now form the characteristic equation. The final characteristic equation becomes s cube plus 6s square plus 8s plus k. Now form a Routh tabular form. Now s cube, first you have to write odd coefficient, s cube coefficient, s coefficient. Next one, s square coefficient, s power 0 coefficient. Here if you take, this is 186k. Now here in our Routh tabular form, first we have to form an auxiliary equation. Auxiliary equation always contains an even powers of s. Here only possibility is s square term is there. Here always row of zeros occurs in odd powers of s. Here only one possibility, s power 1. S cube is not possible, already this value is 1. Now only possibility is 48 minus k by 6. This value becomes 0. From that, k equal to 48. Now form an auxiliary equation. 6s square plus k. 6s square plus 48 equal to 0. S square plus 8 equal to 0. Then finally roots becomes s equal to plus or minus 2 root 2j. These are the intersection point with imaginary axis. Always this intersection point is plus or minus. Plus or minus indicates the root locus is symmetrical about real axis. One is upper half of the our S plane, one is lower half of the S plane. So since root locus is symmetrical about real axis, we already discussed in first point. Now coming to the next one, angle of departure or angle of arrival. Okay. Angle of departure or arrival always calculated for complex conjugate poles, and angle of arrival is calculated for complex conjugate zeros. Suppose if poles are complex conjugate, then angle of departure is exist. If zeros are complex conjugate, angle of arrival is exist. Angle of departure means it gives what angle the pole depart or leave from the initial position. It gives with what angle the pole depart from leave from the initial position is given by angle of departure, that is represented by pi suffix d, that is equal to 180 plus gh, means g of s into h of s. See the open loop transfer function. At positive complex pole, you no need to calculate at negative complex pole. Suppose after calculating positive complex pole, automatically we got negative complex pole because root locus is symmetrical about real axis. Suppose for example, for angle of departure we got 36 degrees at positive complex pole. Automatically at negative complex pole the angle becomes minus 36. Another alternative is there for finding angle of departure, that is pi d equal to 180 minus pi. Where pi is sigma pi p minus pi, that means sum of angles at all poles minus sum of angles all zeros. We have to calculate. The first one is very easy compared to second one, because you have to calculate the angle at only one pole is enough for finding angle of departure. Now second formula, you have to calculate each and every formula by using second formula. Next one is angle of arrival. For this angle of arrival, angle of arrival is exist for when complex zeros are there. It gives what angle the poles arrival itself. The poles arrives on terminates end near the complex zero is called angle of arrival. It gives the what angle the poles arrives or terminates end near the complex zero is called angle of arrival. For a small difference between angle of departure and angle of arrival, this is 180 minus GH. GH means GH is our open loop transfer function. We have to calculate at imaginary complex zeros because angle of arrival is exist for only complex zeros. Only complex zeros. Suppose pi a equal to 180 plus pi, where pi equal to sigma pi p minus pi z, means sum of angles at each and every pole minus sum of angles at each and every zero, that is 180 plus pi, or another one is 180 minus gh at imaginary complex zero. Positive imaginary complex, but no need to calculate negative imaginary. Automatically this is the reverse sign. For example, we take a transfer function g of s into h of s is k into s plus 2 into s plus 4 by s square plus 2s plus 2 equal to k into s plus 2 into s plus 4 by, now you have to find the roots of the denominator equation, s square plus 2s plus 2, s square plus 2s plus 2. Now we can, here the roots of this equation is minus 1 plus or minus j. Now we can write in the form of s minus a into s minus b in denominator. Here these are the roots of the equation, minus 1 plus or minus j. Now we have to calculate the angle at positive imaginary complex pole. Now replace s by minus 1 plus j. Now simply substituting s equal to minus 1 plus j instead of s. Now minus 1 plus j, minus 1 plus j, minus 1 plus b, you have to substitute each and every s value. Now finally you have the angle. If any, the angle is the angle of complex number, you know that the angle of the complex number is tan inverse b by a, tan inverse imaginary component by real component. Here imaginary component is 1, real component is 1, then angle is tan inverse 1. Next you have to calculate my angle for each and every complex number here, then tan inverse of 3 by 1, tan inverse of 1 by 0, like that. Now you have to find the angle. Tan inverse 1 means 45 degrees, tan inverse 3 means 18.43, final angle we got 26.57. then you have to calculate angle of departure. For this angle of departure, 180 minus our GH angle, that equal to 155.53. No need to calculate them at negative complex pole. Directly we can substitute the negative sign. Suppose you got here angle of departure is 153.43, automatically at negative complex pole it becomes minus 153.43. Like that we have to calculate angle of arrival also. Here in this problem the zeros are imaginary. Now we have to find the zeros of the equation s square plus 2s plus 2. Here equations becomes minus 1 plus or minus j. Now we have to form the form the transfer function is like this. Now we have to substitute, replace s by minus 1 plus j. Now calculate the angle of departure in same manner. Okay, thank you.